Obviously, if there are static testing techniques, there will be dynamic testing techniques. Let's find out what they are. Dynamic testing techniques include white box and black box testing. White box testing is also known as structural testing. This involves testing the internal structure of the software. The goal is to ensure that the software source code, architecture, and design are robust and behave as expected. We have various types of white box testing. Statement coverage. This measures the percentage of executable statements covered by the test cases. The goal is to ensure that each line of code has been executed at least once. Branch coverage examines decision points in the code, ensuring that every branch or decision outcome is tested. Path coverage. This tests all possible paths through the code. Condition coverage focuses on testing different conditions within a decision point. An example is if statements, to ensure that all conditions are evaluated as true and false. Loop testing verifies the correctness of loops by testing them with various inputs, including normal, boundary, and error conditions. Black box testing focuses on testing the functionality of a software system without knowing the internal details of its code. Black box testing is based on the specifications and requirements of the software. Types include equivalence partitioning. This divides the input domain of a system into classes of equivalent data. Equivalence partitioning is used to reduce the number of test cases while ensuring that the selected test cases effectively cover the different scenarios within each partition. An example, testing the quantity of items that a user can order online. The valid range for the quantity is from 1 to 10. The website should not allow quantities less than 1 or greater than 10. The partitions will include 1. Valid inputs, which are quantity values from 1 to 10 inclusive. 2. Invalid inputs, quantity values less than 1. Example, -4, 0. 3. Invalid inputs, quantity values greater than 10. Example, 15 and 20. So the test cases here will be test case 1, enter quantity 5, which belongs to partition 1. Test case 2, enter quantity -2, which belongs to partition 2. Test case 3, enter quantity 12, which belongs to partition 3. So this is what equivalence partitioning is all about. It helps us reduce the number of test cases for each partition. Another type of black box testing is boundary value analysis. This focuses on testing values at the boundaries or edges of input domain of equivalent partitions. An example is password length validation. The character must be 6 characters long and the password must not exceed 12 characters. Equivalence partitions will include 1. Valid password length, which is 6 to 12 inclusive. 2. Invalid password length less than 6, example 0, 4. 3. Invalid password length greater than 12, example 15, 20. Boundary values will be 1. Valid password length boundaries, which includes minimum valid password length 6, maximum valid password length 12. 2. Invalid password length boundaries, 1 less than minimum length, which is 5, 1 more than maximum length, which is 13. This explains what boundary value analysis entails. So at the end of the day, we are left with 4 values, the equivalence partition values, and 1 more or 1 less of the equivalence partition values. Decision table testing. This involves creating a decision table to represent combinations of inputs and their corresponding outputs. This helps identify combinations that need to be tested. Compatibility testing. This assesses how well the software performs across different environments, such as various browsers, operating systems, devices, and network configurations. If you like this video, then give it a thumbs up, subscribe, and don't forget to leave your valuable feedback in the comments. I'll see you very soon in the next video.